Okay. So let's move on to the next question, which is question. Yes, I believe yes, we did question A. Now we're moving on to question B, and this one is gonna use the same idea, same principles, and hopefully this way, I'm gonna explain this as much better, much more comprehensive than question A. So let's get started. So B, so we have y equals to cos inverse cos x over 2. Now what I again like to do is to rewrite this. So this is arc cos x over 2. And to implicitly differentiate this, we apply cos on both sides. Arc cos x to the 2. And this will become cos y equals to x over 2. So we implicit differentiated this, and we simplified this because our cos cancels out cos, they cancel out each other, so this would be the simplified version. Simplified. Now we can implicitly differentiate this. So the derivative of cos is negative sine y. Now, since we're differentiating with respect to x, we have to include a dy dx. And 1 over x, which this is the same as 1 over 2x, which becomes simply 1 over 2. So let's solve for dy dx. And this becomes 1 over 2 over negative sine y. Now, the best part, the creative part, where we use a reference. And once you start UNC do more of these practice problems with the reference triangle, it becomes so much faster. It'll click immediately. So the best bet is to just do a bunch of practice. So the reason we're using a reference triangle, put simply, is because this is in terms of y. We need it to get in terms of x. That's why we have to use a reference triangle to relate in terms of x. Okay, so let's draw the reference triangle. Let's go ahead. Oh, wrong color. So we know that this is, what's going on? Yeah, so hype is always 1, adjacent, and there's the opposite, of course. So if we have y over here, and we know sine y, so we have to sort of imagine that this is in brackets of the negative. So we know sine is the opposite over hypotenuse, right? And we know this because of our trusty trigonometry, SOHCAHTOA. Boom, bam, bop. So we know hypotenuse is 1. So this is equal to 1. So now we have to solve for the opposite. So we bring in our trusty friend, the Pythagorean theorem, where let's say adjacent is A, this will be B, and this will be C. So we know already 1, C is 1, A squared plus B squared, and we're solving for B, so we're gonna simply square root 1. If you move the A to the other side, it will become negative A squared. So negative minus A squared. Simply that. And following that, we're going to simply plug this back into our original identity. Or is it we're going to plug this back into this because we just figured it out, which is sine over y is equal to 1 minus x to the square over 1. Again, in terms of x. So now we're going to sub this. We're going to sub, then we're going to sub this into dy dx into our wonderful derivative. So dy dx is equal to 1 over 2 over, let's make that straight. Yeah, so negative, okay, square root 1 minus x to the 2. All right, so again, like we did before, we have to sub our x back in from the original. Sub from original, or let's say from sub x from y. And this would become 1 over 2. Let's write this much neater. Make this much neater. So this will become 1 over 2. Oh no, yeah, let's do this over here. 1 over 2 over actually, let's make this, we can pull this down. So let's make this much neater. So this is the same as 1 times negative 1 over square root 1 minus, again, our x over 2 to the 2. And that means y prime, or dy dx, is equal to negative 1 over 2 multiplied by 1 minus x over to the 2. And we can further simplify this to say that y prime is equal to negative 1. You don't have to simplify, but, you know, we'll go a step farther. Let's make that straight. Eesh. Third term's a charm. All right, there we go. 1 minus 1 over 4x to the 2. And voila. This is our answer. And again, we can double check this by using the memorizing just simply the derivative of the base tan. So we can use the memorization method. So which is, we know the derivative of arc cos, not arc cos, arc cos of x is simply equal to negative 1 over square root of 1 minus x to the 2. And we can test this out by saying, all right, let's give a simple example. What is dx of arc cos? Let's go x to the 2 minus x to the 5. X3 minus 3x to the 5. Why not? Let's make it a bit challenging. So simply what we can do, dy dx, arc cos x2 minus 3x to the 5 is 1 over negative 1 forget your negative. Let's go 1 minus x to the 2 minus 3x to the 5 to the power 2 times the, remember we have to differentiate this again, so we're going to take the derivative of this d dx of this, which is simply 2x minus 15x. We brought down the 5, multiplied it by 3, 15, and then minus 4. And there we have it. Oh, wrong thing. And there we have it. You can double check this, double check the problem, the solution here with this method and see if it works. Obviously it's most faster, but proving these steps that we just did here, from going from this, using the reference triangles, Pythagorean theorem, and then eventually plugging it back in for dy dx, goes a step far and beyond. But once you understand this, how we get this, then you can simply, you understand, like, using these mechanics will immediately get you there. Like you see, there's always a negative at every derivative of inverse cos x to something. So there we go. That is it. This is our wonderful answer, and there we go. So let's keep going. All I said, it's practice. Okay, sweet. Have a great day. Ciao.